Good morning, everyone, and welcome to today's Go Fly Master Lecture. Go Fly is sponsored by Boeing, and as just announced this morning, is also joined by new corporate sponsor Pratt & Whitney, who's sponsoring the $100,000 Disruptor Award. And in addition to the prize sponsors, Go Fly is also joined by a number of in-kind sponsors and organizational partners who are excited to have along on the Go Fly journey with us. Today, we're very pleased to be joined by Rich Golaszewski, who is partner and executive vice president of GRA Incorporated. He has also conducted a number of assessments of technology development programs and written on the economics of aeronautical research and technology investments for NASA and other organizations. He was a member of the Aeronautics and Space Engineering Board of the National Academies for 6 years and was named a Lifetime National Associate of the National Academy of Sciences in 2003 for his significant pro bono involvement in its aerospace and air transportation activities. Rich received a BS in accounting from LaSalle College and an MPA in public sector management and finance from the Wharton Graduate School, University of Pennsylvania. He was a military officer and helicopter pilot from 1967 to 1972. And we're so excited to hear Rich speak to us today. So Rich, with that, I'm gonna go ahead and pass it over to you.
Thank you, Paul. Thanks for the nice introduction. I thought maybe something I would talk about is how does a transportation system fit in, a new technology, and how does one look at the market for that, rather than getting into production economics and more complex subjects. So what I've done is I've put together a slideshow. I'm going to try to stay out of the gory details. And we'll go from there. So with no further ado, let me get started so I don't use all my time up. I'm still not in the mode. There we go. Okay, great. So when I looked at this, the idea of self-flown aircraft and individual piloting has been around for an awful long time. I mean, that was really the beginning of aviation. Today, we're seeing an emergence of a lot of people believe in urban air taxi, even an automated one that was small, designed to carry a few people, can be self-flown. There was a demonstrator that was flown last week that was an automobile that turned into an aircraft. And these are all generally independent of needing a runway. Some people even envision these as being autonomous. You just hop in, on your commute, do your work, and the vehicle gets you there. And there's interest of these in both the civil and military sectors, as there has been for a long time. I'm going to start with just a few examples of the past, and then we can move from there. This is a 1945 experimental helicopter. It looks like it carries about one person. It had coaxial rotor, so it really did not need a tail rotor. It was just an experimental aircraft by Bendix Aircraft. They were actually in the helicopter business in 1945. My personal favorite is the Taylor Aero car. This one is in the Boeing Museum in Seattle. Basically, it was a car that either towed its own wings or its wings rode behind it in a trailer. And then when you wanted to go from a car to an airplane, you installed the wings, I guess, and the tail and everything, and it became an airplane. You can actually find some of these still for sale if you go out and Google it. But it's always been my kind of favorite. It's sort of popular mechanics circa mid-1950s. But that was the vision back then. The next one is the military always wanted a way of getting a soldier above the battlefield to see what was going on. And they actually developed some early platforms. This one was built by Hiller, which was a helicopter manufacturer. The pilot stands in that cage in the middle overneath a rotor, which is going around in the big circular device. And the idea was to lift one soldier and that soldier's gear, including a weapon, so they can do observation missions. It really wasn't designed to be an offensive weapon. So that's some of the history of, this has been going on for a very, very long time. I think the new things we're seeing are both, can you do it with an electric motor? Can you make them autonomous? On this, let me present some things that might be helpful if you want to get beyond just making a demonstrator, and what if aircraft design or development becomes part of your future? And the key to understanding how a vehicle, a service, or something fits in is to use a technique called choice analysis. It's been used for both surface transportation, air transportation. It's actually the core of airline network planning modeling. And what you want to do is you want to examine the demand for travel and how does it fill a market need? How many people would select it? Because that's what people want to know. How big is the market for what you're doing? Is it big enough to support a development and production program? I'm going to look at 3 different prior studies which have sort of gone from a new service model, then to a new vehicle type, and then to a new transportation system. And then there's been some very recent survey work on urban air taxi service, which the authors were willing to share with me, and I thought I would share it with you because there really is a ton of interest in this today. So transportation demand, people don't, I guess some people fly around just to buzz holes in the clouds, but generally the demands derive for something else you want to do. You want to commute, you want to shop, you want to go on vacation or a business trip. And it's really framed by how do you choose what you're going to do? Are you going to drive? Are you going to fly? And you make a comparison and you look at what economists call the full price of travel. What's the out-of-pocket cost, including the fares, any other fees to access a departure and arrival points? It also includes your value of time in transit and cost to access and egress the mode. So, and you can do a lot of different things. Scheduling turns out to be really important to people. When can I get there? When can I leave? So that's also an important factor in travel choice. More flights in a market are better than less. People get more choices. You're closer to people's desired travel times. So this choice analysis has a long history of use in transportation and in market research. How do you place a new product in the market? How do you find out what people want? And it really requires defining the choices on offer. When people make a choice about travel, what are they choosing between? What's the next best way to do it? And people also consider other things. They consider the type of vehicle. I want to be on a big aircraft rather than a little one. I want speed. I want comfort. And demography ends up explaining a lot too in travel choice. And these are modeled with what's called a discrete choice model, which is really a statistical approach. And then when they're very refined, you can actually convert that into a factor model of scoring sort of alternatives. There's 2, how do you know what people want? I mean, this is the sort of key question. And there's really been 2 approaches to doing this. The first is reveal preference. You model new and existing services from choices made in similar markets. So how do people value a nonstop flight versus having to connect? Is there any value? Do people see a value in flying on a wide-body aircraft versus a narrow-body? How does service frequency, how many flights a day, matter? And this is the piece that underlies most of the airline planning models. They all started out with this statistical framework. They've all been sort of converted to scoring models for preference. A nonstop is worth 1.5 points versus a connection is worth 1 point or something. So they make them simple so they can apply them repeatedly in deciding what markets to go in and out of. That works if you have something similar. So because you can get parameters to look at what people are selecting by. The next way to do it is what's called stated preference models. And these use surveys to find out what people value and why. So they work well for vehicle types that don't exist. And they also work in a number of other contexts, things that aren't traded in markets. How much do people value clean air? How much do they value access to a park? And things like that. And there's a whole thread of environmental economic literature, which looks at things like that. You know, there are issues when you try to do this for a technology that's not yet available in the market, because you're asking people to tell you what they would do, but they've never really faced this choice before. So you present the new alternative as a bundle of attributes. The models don't necessarily account for what wasn't available in the market when the analysis was conducted. And a real good example of this is nobody really understood how much consumers didn't like turboprops until the regional jet came along. And then it's basically, over the years, replaced the turboprop in the market. It was way underestimated how much people valued being on a jet. And when you think about it, you know, being able to get above the weather and things like that really mattered, because it was a much more pleasant ride. Having done a number of turboprop flights in my life, I understand you really get sort of down in the weather, getting bounced around more often. We're going to look at these three different examples today. The first one is just a new service. We did a study way back when of a concept called Cochairing, and this had been in use where commuter airlines and major airlines put their same call sign on flights and coordinated schedules, but this was international now, and I'll explain that. We looked at very light jets. They were very popular in the mid-2000s. There was actually a service started based around an aircraft type, the Eclipse 500. We'll talk a bit about that. The idea of this study was to look at what's the potential demand for a vehicle providing different services. It was a small vehicle. It was oriented more towards short haul than long haul. And how did we look at that? And then I was involved in the Civil Tiltrotor Development Advisory Committee in the late 1990s, which really looked at, could you establish a new transportation system? It would be point-to-point. It also offered a lot of benefits in alleviating congestion at major airports. So I'll walk through these. I'm not going to get very deep into them. I'm going to kind of just illustrate how the analysis was structured and then talk about what we found out. The first one on code sharing. Doing this internationally was the big innovation. There are ownership laws. So if British Airways wants to fly into secondary markets in the US, it had no ability to run its own flight. So it couldn't fly to New York and then continue on to 4 other different places. And this came about, you know, the airlines were originally called the flag airlines. So there were a lot of restrictions on airline ownership. There were a lot of restrictions on who could fly in what markets. And US carriers and foreign carriers came to the Department of Transportation saying, we want to enter alliances. We want to share codes so that British Airways and American Airlines, for example, could sell their flight interchangeably as an American flight or a British Airways flight. And the Department of Transportation wanted to know what were the benefits and costs to US consumers and what were the benefits costs to airlines. I mean, this was sort of the public policy choice. Was this something worthwhile? And as I said, ownership laws were an issue. We estimated a model which added code sharing as an option. So we ended up with what you call an online flight, everything on the same carrier, a code share flight, and then typically what happened internationally at this point in time was you had an interline flight. So I would fly American Airlines to London, and then I would switch to British Airways to fly somewhere within Europe. So we wanted to assess what was this new flight offer, and the difference in a code share and an interline was that code sharing, the carriers actually worked together. They tried to locate the flights in the airport terminals adjacent to one another. They timed the flight so there were convenient connections and things like that. We used a reveal preference model based on the US DOT ticket service survey and other information. And again, we looked at 3 kinds of service and what people valued. And we use that data from that analysis to look at code sharing. Here's an example of what I mean. You can have country A and country B. They're each different countries. So the airline Y flies in markets in country B, airline X flies in country A. And only they can serve the airports behind their major airports. So all the subcomponents of B, the little branches coming out, only Y can serve because they have rights to serve that market. Conversely, X has the right to serve everything between A. What they did was they came up with the idea of, well, either one of us can fly A to B. That was allowed anyway. What we want to do is we want to put the same code on a flight that went behind A or B, or came from behind A or B, and we could run them as a single offer. You would see it in the reservation system as one flight. I want to fly from Peoria, Illinois to Manchester, England. Well, there's no service in that market except via connections. And that was the concept that became the beginning of code sharing internationally. We did the original model in 1994, focused on BA US Air. That was the original deal presented. And it's the one we had the most data on, frankly. And then in 1996, the work was updated to look at BA US Air again. And then there were two other major alliances that had formed, KLM Northwest and United Lufthansa. Now, Northwest doesn't exist anymore. It's part of Delta. And Air France is in an alliance with KLM, so it's now the Air France Delta alliance, but it has all these subcomponents in it that started back then. And we looked at, would you get more traffic? Would traffic be stimulated from improved service? We found that the impact on U.S. consumers was positive. There were some transfers among the airlines depending on who flew the route. So generally, whoever flew the long-haul flight did somewhat better than who flew the short-haul leg. Now, this was back in the mid-90s. Code sharing has changed markedly in the past 20 years because the underlying markets have changed. Airlines have received antitrust immunity for these alliances to allow discussion and coordination affairs. That's something new. We've had a large reduction in the number of U.S. mainline carriers via mergers, and we've had increasing hub dominance in both U.S. and foreign carriers. So the market competition dynamics aren't necessarily the same today from when we looked at these in the mid-90s. So we're not sure what we would find if we tried to replicate the work today. But my sense is that the concept is so baked in, it's not going to be undone. Our second example, we looked at a new aircraft type. And this was sort of started in the early 2000s. It got really hot sort of in the mid-2000s, where people started to develop very light jets. These were jets that would carry, 3 to 5 people. And they were seen as potentially revolutionized using certain air transportation markets. They weren't necessarily long-range vehicles, but they got you from A to B very quickly. And the ACRP Airport Cooperative Research Program, which is funded by FAA, wanted to identify, well, what's the impact of VLJs on airports? And what could airports do to prepare for them? With this, Eclipse was offering a 4-seat jet at $1.5 million. Well, they had development issues, certification issues, and the price was up over $2 million after a few years. They had underestimated their own costs, their own ability to deliver a certifiable product. There was actually a service started by a company called Dayjet, which was quite novel in their business model. They started service in Florida using the early Eclipse aircraft. And it was actually, their business model worked well. The problem was that they didn't understand how much cash they needed up front before the thing would turn profitable. So actually, Dayjet went out of business. Eclipse was restructured, and they're still making and selling Eclipse aircraft today. The model we posited of a point-to-point service market really hasn't evolved yet. The way we did it is we looked at all general aviation flying, including traditional general aviation, for private, personal, or business use, air taxi service. We looked at different kinds of aircraft, high-end piston aircraft, very light jets and light jets. And the study covered the lower 48 states only. An airport had to have jet fuel availability and a 3,000-foot runway so the VLJ could operate on it. And we excluded the largest airports from the analysis. Where did we get our data? Well, a lot of this was going to replace driving. So we had a travel demand data set from 1995 that we updated to 2007 to find out how many people wanted to fly from A to B. And then we defined the new mode attributes in a revealed preference analysis. And DayJet's business model was actually quite interesting. The first person to reserve paid a higher price but got to pick a departure time. Once that was set, other people could offer to join that flight as passengers, and they got a discount, but they didn't get to pick the time the flight left. And we looked at the spread of VLJ service versus traditional charter service, and we ended up estimating operations by airport. Sort of a very big, complex filtering down model to get down to about 1,800 airports at the end of the day. There was certainly perceived price sensitivity. It made sense if you could get one or two people on board. If you only got one, you didn't do well. If you got three, you did very well. It was that sensitive to pricing and loads. And we made some assumptions about where the flights would be offered. As we said, they were already started in Florida with DayJet. And then we assumed they'd be available sort of around the country by 2012, really along the coasts, because the coasts tend to have long travel times. So we thought that would be, that's the first place they would go, and they would eventually end up in the Midwest. What happened? Well, DayJet went out of business. Again, the model was brilliant. The guy put together, and he put a lot of his own money in it. But the aircraft came online too late. They weren't fully certified to fly in thunderstorms and other conditions. And it just took a while for Eclipse finally to get the aircraft fully approved to operate in all conditions. The Civil Tiltrotor Development Advisory Committee was an interesting thing. This was around when the B-22 was just being worked on for the military. And people wanted to look at, well, could this have civil transportation opportunities? Because it had unique operating characteristics. It was like a helicopter in that it didn't need a runway, or only a very short one. And then when it rotated the propellers down, it flew like an airplane, so it was fast and went far. And that was a new, unique vehicle type. So we looked at what operational concepts there were. And this has some similarity to the current urban air taxi. We looked at flying from a heliport to heliport or vertiport. Could you use it to fly from secondary places to and from a busy airport because it wouldn't need a runway? And, could it operate independently of main carrier runways? If it could, then this could do a lot in reducing delays at some of the more congested airports, such as Newark, LaGuardia, and so forth. And we actually started with a model developed for Northeast Corridor travel services. It was really, I think, the Amtrak model at the core, where they looked at new trains versus air transportation and things like that. And then we modified it and adapted it so it would represent civil tiltrotors. we examined the thing from cradle to grave, as you say, you know, from research and development through somebody actually deciding to produce an aircraft and production costs, the economics of flying it, how much did it cost to fly, what kind of fares could be charged, what risks and uncertainty were there. It needed a lot of new infrastructure for these vertiports. They needed to be placed around to make the system work. So we actually costed those in. And some of those factors we looked at actually matter to passenger choice. So CTR safety matters. Infrastructure needs and costs and location really matter to passengers. And the economic and financial outlook, what would the fares be? Would they be affordable? We examined that, and the study kind of said, well, this could work. There really wasn't an appropriate vehicle type at that time. So in one sense, it was probably looked too far in the future, but there is a market for something like that, which could evolve. As I started out saying, there's been a lot of interest in this urban air taxi market. We're seeing just all sorts of examples, aircraft, conceptual aircraft being shown. Somebody flew a car last week that operated like a helicopter. There are a few more under development. So this really seems to be the thing that's coming on heavily. And there were two real studies of it. I mean, people like Uber are involved. I mean, these are people who are big players in the market. So there's a lot of interest in this. So there were two surveys on passengers' willingness to use it. And the first was conducted by Dr. Laurie Garrow and her colleagues at Georgia Tech, and it was trying to predict demand in a number of markets, and they made a presentation of it in Hong Kong, which they were willing to share with me. And then second, a gentleman named Nicholas Dunn wrote a master's thesis on it that came out in June of this year. He was at MIT and conducted a study of the Dallas-Fort Worth area. Both projects used stated preference surveys. So they were asking people, would you do this? Why would you do it? What's important in your choice? And we'll see what they found out. The Georgia Tech study was actually funded by NASA, and it really came about from this idea of electric propulsion is going to be achievable. You'd be able to do battery-flown aircraft. They wouldn't necessarily fly super long ranges, but they'd be very economic for very short-haul transportation. So they asked Georgia Tech to assess the potential market and what do people react to it, how did they react to it, and what attributes of this did they value. The study itself, including all the surveys, is not yet completed. I would expect it would come out later this year. Here are two conceptual vehicle concepts. The Joe BS2 looks like a helicopter with multiple rotors. I think the idea here is that if you use a lot of small rotors versus one big rotor, the noise goes down a lot, and you can power them independently with different electric motors. So it would provide an additional level of safety. The Lilium flies more like an airplane. It's a VTOL electric airplane, so VTOL means vertical takeoff and landing. I haven't quite figured out how it does it, but I do think the wings and certainly the things up front tilt, which give it some vertical lift. So the major sections of the survey, they did a quite structured piece of work. They screened people so they could classify them. They asked their opinions about travel. The idea was people could fly above the traffic. So they asked them about how they commute, how long, There are a lot of people in this country who have very, very long commutes. And then they introduced them to this new air taxi service. And what were the design features? And then what were some of the trade-offs? They're targeting 2,500 respondents. They've had over 1,000 to date. And they focused on 5 metropolitan areas that have particularly long commute times: Atlanta, Boston, Dallas-Fort Worth, Los Angeles, and San Francisco. So the idea is, well, it's not going to work if you have a 10-minute commute. But if you have an hour-and-a-half commute, it might be very attractive. And then they provided them with a description of the attributes of the vehicle and what the service would be like. So they said it would be battery powered. It would carry two to four people. Initially, they asked people to assume a pilot was on board. But I think, one of the questions here is, will people fly on something that is fully automated? I'm not sure they will or won't. I think that's a question that's open. It assumed it wouldn't fly in hazardous weather, so you weren't up at low altitude and thunderstorms. It would fly at helicopter-like speeds, 100 knots. But it'd be much quieter for both the occupants and those on the ground. A lot of it is this multiple rotor concept. Actually does have a benefit of reducing noise, and it would meet FAA stringent safety standards. That to me is going to be one of the key issues, because if you're providing a transportation service, then you have an obligation to the passengers who may not know much about maintaining safety, and that is usually what becomes a long pole in the tent. Can you prove the safety case? Because you won't get certified unless you can. The MIT study was looking at operational constraints and what customers valued. It was based on an MIT student thesis and identified 19 operational challenges. So this student had this idea. He actually cooperated with Bell Helicopter on it. Bell was quite interested. They make small helicopters, and concepts like this would be of interest to them. The biggest constraints were, would the community accept the noise, and would there be takeoff and landing areas? A lot of what stop services like these located close to people's houses is nobody wants the landing and takeoff area in their backyard. That's the usual. So you've got to be able to find places to operate that people will accept. It proposed short-range transportation, basically commuting, but in areas that have commutes of an hour up to 2 hours. So it would be a lot quicker if you could do this. One of my personal issues is, will it be a lot quicker if everyone does it? I don't know. They really think that this technology is coming. You'd have these, they'd be fueled by quiet, efficient, automated vehicles eventually. There are a few on-demand helicopter services beginning operation. They're different than a traditional charter where you just go charter the helicopter and you pay 100% of the cost and you have to fill it. This is a company called Blade in New York City is now offering seat charters where they say we're going to fly from the Wall Street heliport to the Hamptons. And on a Friday night, that's about a 3-hour ride in the car. And they say, we'll get you there in 25 minutes. It's quite attractive. It's created some controversy out in the Hamptons and across Long Island with all the flight traffic, but people will pay for it. Actually, one of the bigger areas has been in Brazil. Sao Paulo and Rio both have horrible commutes, and there are helicopter services targeted at the large end of the market. And the company called Boom launched in 2017. It's expanded to Mexico City and is planning Rio. For those of you who are probably younger than me, there were urban helicopter services in the U.S. in the early 60s. There was one that went around New York and shuffled people from downtown to the airport and things like this. So it's not an alien concept. It's just that the ability to make money and operate safely and quietly turned out to be the very difficult things to overcome. We also took a quick look at something, I guess no, actually the MIT student took a quick look at what Uber's identifying as challenges for these automated vehicles to operate. You know, could you get the vehicle itself certified? Could you prove it was safe? What about battery technology? Is it there yet? Can we fly the required distances between needing a recharge? How efficient is the vehicle? Is it reliable? How do you fit this into the air traffic control system? It's going to have to be separated from other aircraft, including aircraft flying at very low altitudes under visual flight rules. And that seems to be something that they're going to have to face if you ever want to do something like this. What about operational safety? Can you assure that you'll be able to operate into and out of places safely? Noise, issues, building infrastructure, pilot training, and then of course the cost and availability of the service itself. So these seem to be the big challenges, but you know, nobody would have thought 10 years ago about the Uber model, which has really grown like a weed and has taken over, and actually is a lot of the commercial taxi services are suffering a lot because Uber really had a new concept, and it turned out it's something people wanted. So if you meet what the market wants, you'll succeed. The survey that was conducted by the MIT student had over 500 respondents. Less than 30% of the people had heard of this urban air mobility, urban air taxi concept. In Dallas, 49% said they would likely use the services, and 29% said they would not use the service. But I was surprised by the 49%. Now, would they really do it when faced with an actual choice? I don't know. People cared the most about, well, what does it cost and is it safe? Which I think are natural. Those are what people really end up caring about. Almost half said they would fly in a vehicle that was autonomously flown, i.e. without a pilot. I find that a bit hard to believe, but you know, I'm probably a skeptic on that. I don't know. I think people today are more willing to accept that computers can do everything. And the non-users were most concerned about noise and safety. Would this create noise around where I live? Would it come crashing through my ceiling? So, but that's what the survey was meant to design. So the two survey research analysis, what did they show us when it was all said and done? There are methods to look at new air service models and new technologies. Urban air taxis will be a new travel choice. People don't have that choice today. And they have to be evaluated as, how does this square up relative to what I'm doing today? Are there other choices? What else could I do? The initial survey suggests there's some demand for this service and what people would like from it. Of course, they raise the issues of cost and safety. They're always primary in what comes to people's minds. And there's questions about how to integrate it with other types of aviation activity. And I think that's going to be the real hard one, because there's a lot of uncontrolled airspace at low altitude, and a lot of people are operating in it, and you don't necessarily know where they are because they're not broadcasting a signal. So that's kind of where we got. We kind of went from the beginning of, you know, what's been the interest in this technology over time? How do we look at markets for new services, for new vehicles, and for new systems? And then what's happening today that's important? And it looks like the thing that's most important is this urban air taxi model, and can it be made to work? So that's what I wanted to talk about. Any questions or comments?
Thanks, Rich. Yeah, let's go through a couple of questions. So you talked a lot about the need for new models in aviation. Could you just expand a little bit on some of the sort of things that people might not be thinking about in regards to some of these personal air traffic things that might sort of spring up, like the Uber model, that are just sort of completely out there right now?
Yeah, I think, what you have to do is you have to have, something that's reliable and relatively inexpensive to operate. First, you need, so that's really a production and development question. It's not one I'm not an engineer, but that's really, can you engineer something that would work? And people really don't like commuting, especially long distances, but they do it because they have lifestyle choices of where their family wants to live and do things. So this may be a good way of tempering, I couldn't imagine a 2-hour commute each way in my life. I just don't do it. I wouldn't do it. But some people have to do it every day to earn a living. So that's really what it's initially pointed at. And it's sort of set up in this more free-form model. So, the way it's being conceptualized is you don't go to the airport 2 hours ahead of time. Go through all the hassle of security. The idea is show up and go. And we'll have to see if that works. But that's really one of the concepts. I can do this quickly, easily. It's going to be close to my home, and it's going to end up close to where I have to be, work or wherever else I want to go.
And then can you talk a little bit about the interplay between what it takes to get a vehicle off the ground in terms of technology and expense, and how that juxtaposes to the potential price points that people might be interested in terms of using a flying vehicle as a commuting option?
Well, I guess the first thing you have to sort of understand, and it's sort of a standard joke in the business, if I had a nickel for every paper aircraft that I was shown, I'd be a rich man. People underestimate what it takes to get something designed, developed, certified for use. That was, that was part of Eclipse's problem. They underestimated how long it would take and what it would cost just to meet the basic safety standards. It's probably going to take, it's a lot more than producing the first prototype. You've got to prove it's reliable, you got to prove it's safe, you got to prove fuel consumption, also energy use, all sorts of things before you can even get started. And people underestimate the effort. And as a result, they underestimate the cost. So that's why we only see in the commercial end of the world a few aircraft manufacturers who've managed to understand how to do that. I mean, Boeing's struggling now with deciding whether to launch a new aircraft. And it's going to come down to what's it going to cost to develop and certify it? How big is the market? Can we sell enough to recover our cost? You end up with these things with very high upfront costs, which you then have to recover by selling a lot of them over a relatively short period.
Yeah, so that brings up another interesting point about scale. So people in the Go Fly competition right now are probably very concerned with prototype number one and the revisions to that prototype. Could you talk a little bit about what it takes to switch from thinking about a prototype to something that is available to many people, which will require a manufacturing scale that looks a lot different than prototype building?
Well, I think that, basically, the prototype people do. They do one-offs. There are people flying these things, some prototypes today. But to go from that into something that you can produce consistently, reliably, that is safe, has decent operating economics, that's a whole nother level of effort. And you really have to, is there going to be a demand for it? Because all these programs, as I said, have very high upfront costs. So you end up having to sell a reasonable number of them to make the program profitable. If you don't hit your numbers quickly enough, the program will never work. So, and that's the big transition is going from, I've got this concept, I'm flying my prototype, to what will it take to get this thing developed and produced? That generally implies an efficient production line, a supplier network, and all those things that you have to do.
Great. And then transporting people and transporting goods, product delivery, might have the potential to be combined with some of these types of vehicles. Have you thought about or looked into the potential economics and adoption of systems that might combine people transport with product delivery?
I haven't looked at them specifically. I think you're right. That is a concept people are talking about. People are talking about them for just delivery alone. And I'm trying to understand sort of the distribution systems people have. And would you fly it to the doorstep? I think not, but you might fly things to a central area located where there's a lot of people, and then just distribute from there, cut down your over-the-road costs and over-the-road time. May be the best thing to do, and you people are already flying demonstrations of product delivery. And again, you've got to meet the safety standards. Can you be in the airspace?
Great. And during your talk, you mentioned the switch in aviation from turboprop to jet engines. Do you see any sort of future-looking predictions about what the future propulsion of personal transport might look like?
I think everybody is looking at electric. That seems to be the new big thing. And, if you can do it, it has a lot of benefits. Certainly, distributed rotors, distributing the power so that you don't have one big motor, that you've got a lot of small motors doing it. Helps in a lot of different ways. It makes it more reliable. You can have software, if you lose a motor, the software can readjust the rotors. And what they're doing, so I think that's coming. I think electric aircraft will come. I think, sort of the days of the avgas-powered small airplane are numbered. Avgas is, not good on an emissions front, and a lot of those aircraft are extremely old. So there is a market there, even for personal flying. I think there's a market.
Great. And then as we wrap up here, do you have any final parting words of advice for GoFly competitors, things you think are really important that they should consider on their GoFly journey?
Well, I think they have to consider, where will this thing be used? How will it be used? Other than sort of coming up with something that meets the contest performance criteria, what happens if it goes beyond that? Where does it go after that? How can this be used? Because that's what people want to understand is, all right, you've shown me you can do this. Now, how can I use it to open a market or make money? And that's always the next big step.
Great. Thanks so much, Rich. We really appreciate your time and effort put into your master lecture. It'll be hugely helpful for the GoFly community, and really appreciate you sharing all of your great knowledge with us here today.
Great, and again, I would like to thank GoFlight. I found this to be just extremely interesting and valuable to me.
Great. Thanks so much, Rich.
All right, thank you.